نحاول مع بعض نفهم بعض المصطلحات، نستنتج بعض القوانين، نحاول نركز ونشوف درسنا النهاردة. My dear students, let's start with our lesson today about what's meant by chemical equilibrium. But at first, my dear students, I want you to know what's meant by physical equilibrium. My dear students, I want you to be concentrated with us to know at first what's meant by physical equilibrium. Physical equilibrium, this process, it is proved in our nature by studying some cycles of gases such as carbon dioxide, nitrogen, and oxygen. Now, my dear students, let's see an experiment to know what's meant by physical equilibrium. Here, my dear students, what's meant by physical equilibrium? As we said, the kind of equilibrium is proved in nature by cycles of oxygen, nitrogen, and carbon dioxide, as we said. Now, my dear students, let's deal with this experiment to know or define what's meant by physical equilibrium at first, as we said. If water in a closed vessel is heated, we notice that two opposite processes happen: vaporization process and, yes, condensation process. On starting to heat, vaporization is the main process which takes place, so the vapor pressure increases. Now, what's meant by vapor pressure? Yes, it is the pressure due to the water vapor in air at certain temperature. Here, my dear students, if we look, if we get some water and try to heat them at first, as you see, my dear students, vaporization process increases. Then gradually or by continuous time, the vaporization decrease and condensation increase. So most of us, yes, consider that at first one process increase and at last the second process increase and the first one is vanished. This is not true. Why, my dear students? The vaporization process continue until vapor pressure equal saturated water vapor pressure. Here we deal with the second item. This item is called saturated water vapor pressure. What's meant by saturated water vapor pressure? Here it is the maximum water vapor pressure in air at certain temperature. So, my dear students, at equilibrium, the rate of vaporization equals the rate of condensation. Here, my dear students, I want to explain this process. As we said, when we heat or boil some water in a closed vessel, we notice that at the beginning, the vaporization process increases in its rate. At last, the condensation process increases in its rate. But this is not true. Why? Because at equilibrium, the rate of vaporization equals the rate of condensation. So from this we can explain or getting for what's meant by physical equilibrium. Physical equilibrium, my dear students, means that a stationary system apparently but dynamic in reality. Again, it is a stationary system apparently, but it is dynamic in reality. Let's see this definition with us. Here, my dear students, what's meant by physical equilibrium? Again, what's meant by physical equilibrium? It is a stationary system apparently. If we look at it, we notice that it is constant. Yes, but it is dynamic in reality because we said that the rate of vaporization equals the rate of condensation. This means that the two processes exist, but the rate of them are equal. Now, my dear students, let's move to define what's meant by chemical equilibrium. At first, I want you to be concentrated with us about what is meant by, yes, chemical reaction. I think all of you know that chemical reaction has two types. The first is a reversible chemical reaction, and the second is reversible chemical reaction. Again, my dear students, there are two types of chemical reactions. First is irreversible or complete. The second is reversible. What is the difference, my dear students, between a reversible chemical reaction or complete and reversible chemical reaction? The first type, which is called a reversible chemical reaction or complete, is the reaction that moves in one direction only. Again, the reaction that moves in one direction only. What is this direction, my dear students? It is the direction of formation of products. Again, it is the direction of formation of products. So the reaction moves to the formation of products and complete. My dear students, I want you to be concentrated here because we deal with some chemical reactions in our curriculums of science before about this type of chemical reaction. If we add zinc to hydrochloric acid, what is the result, my dear students? Again, if we react zinc with hydrochloric acid, Zn plus 2HCl gives what, my dear students? ZnCl2 plus H2 gas. This gas evolves. What's the meaning of evolves? Get out from the medium of reaction. Another reaction is the reaction between silver nitrate, AgNO3, and sodium chloride, NaCl. This gives what? Gives sodium nitrate, NaNO3, and AgCl precipitate. So, my dear students, if we notice these two reactions, we notice that one of the product escape from the medium of the reaction. Hydrogen gas in the first come out, evolves, and AgCl or silver chloride precipitate. So the reaction complete or finished. The second type is irreversible, where all reactants and products is still in the medium of reaction. Let's see, my dear students, these two types of reaction with us. Here, the types of chemical reaction. First, the irreversible chemical reaction. It happens usually in one direction, as we said, in the direction of products formation, because one of the products escape from the reaction medium in the form of gas or in the form of precipitate. Again, here, my dear students, we explain what's meant by, yes, a reversible chemical reaction or complete. It happens usually in one direction. Means what? In the direction of products formation, because one of the products escape from the reaction medium in the form of gas or in the form of precipitate. Here, if we notice the equations in front of you, first, Fe or Zn, any metal elements, react with 2HCl hydrochloric acid dilute, gives FeCl2 and H2 or hydrogen gas evolves or comes out from the medium of reaction. Another equation, my dear students, NaCl plus AgNO3, yes, gives NaNO3 or sodium nitrate plus AgCl precipitate here, my dear students. So it comes out from the medium of reaction. In these reactions, we notice that one of the products comes out from reaction. If we move to the second type of chemical reaction, as you see, reversible chemical reaction. Here, my dear students, in this type of reaction, as we said, the reactants or all reactants and products is still in the medium of reaction. This means that no of the products escape from the medium of reaction. So, if we explain this type, we can find this is different from another type of reaction. Let's see here what's meant by reversible chemical reaction. Here, it happens in two directions, forward and backward directions, because the reactants and the products are found in the reaction medium which reach to its equilibrium. Again, here, my dear students, the reaction may be moved forward or backward. So, in the two directions of the reaction. I want you to be concentrated about these graphs that explain the two types of chemical reaction. If we notice, I want you to be concentrated and try to elicit the types. Here, my dear students, reactants, products, after reaction, they still in the medium of reaction, while here, my dear students, if we start with reactants, its concentration or amount decreases gradually, while the products increase gradually. So this is complete or irreversible reaction, while this type is called, yes, excellent, my dear students, reversible chemical reaction. دلوقتي بعد ما قدرنا نعرف الفرق ما بين التفاعل المنعكس والتفاعل الغير منعكس أو الكامل، نروح مع بعض فاصل ونرجع نستكمل درس النهارده. أهلا بكم أبنائي وبناتي مرة تانية، نستكمل مع بعض درسنا النهاردة. Today we will explain, yes, chemical equilibrium, and we study the difference between the two types of chemical reaction. The first, which is called irreversible or complete, and the second is called reversible. My dear students, I want you to be concentrated about in reversible reaction. This reaction reaches to the point of equilibrium when the rate of the backward reactions equals to the rate of forward reaction. When the reaction moves in the two directions with the same rate. Now, what about the rate of chemical reaction? Let's see. Rate of chemical reaction means what? It is measured by the rate of change in concentration of reactants or products per unit time. Again, the rate of chemical reaction, it is measured by the rate of change in concentration of reactants or products per unit of time. Also, the concentration unit is mole per liter. It is clear for you to know that concentration unit is mole per liter. And the time unit is, yes, minute or second. Now, my dear students, let's move to another part of our lesson. In this part, we will talk about the factors that affect the rate of chemical reaction. All of you know that there are many factors affecting the rate of chemical reaction, such as what? Such as, yes, concentration of reactants, yes, excellent, temperature, pressure, yes, light, catalyst, also the nature of reactants. Again, there are many factors that affect the rate of chemical reaction. These factors are nature of reactants, concentration of reactants or products, also, my dear students, temperature, light, catalyst, and light. Now we will explain with us these factors. Factors affecting the rate of chemical reaction are, as we said, nature of the reactants, concentration of reactants, temperature of reactants or reaction, pressure, catalyst, light. I want you to be concentrated here because these are the factors that affect the rate of chemical reaction. Let's start, my dear students, with the first type. The first type here, my dear students, is the nature of the reactants. What's meant by nature of reactants? Yes, here, if the reactants contain ionic bond or covalent bond, is there is a difference between the reactants if they are ionic compounds or covalent compounds? I want you to be concentrated and think carefully. Here, if we react compounds and these compounds have ionic bond, what do you observe, my dear students? And what do you conclude from this reaction? All of you know that ionic compounds results from reaction between, yes, excellent metals and non-metals. And this type of bond is called, yes, ionic bond. So when the ionic compounds react with each other, it may be separated into positive and negative ions, and it is easily to exchange of these ions. So the reactions, my dear students, yes, occurs faster. Why? Because ionic compounds separated or divided into negative and positive ions. And these ions of the reactants exchange with each other and the reaction takes place quickly or faster. But in case of covalent compound, I think all of you know that covalent compounds results from, yes, sharing of electrons between the atoms of the elements. And they may be, yes, single covalent or double or triple covalent bond. So when the covalent compounds react with each other, they need more energy to break down the bonds between molecules at first. Again, when the covalent compounds react with each other, they need more energy to, yes, break down the bonds between the molecules at first, then the atoms or molecules combine with each other. So we need more energy, so this reaction occurs slowly. So my dear students, if we compare between the reaction takes place between ionic compounds and the reactions that takes place between covalent compounds, we notice that the reactions of ionic compounds occurs faster than the reaction that has covalent compound. Let's see here, my dear students. Ionic compounds react very fast, as we said, because what? Because the reaction takes place between ions which combine with each other when they are mixed together. As we said, the compounds, yes, contains ions, and the ions react faster with each other to form new compounds. Yes, if we notice this equation, here the reaction between silver nitrate, EgNO3, plus sodium chloride, NaCl, gives NaNO3, sodium nitrate, and AgCl. If we notice the, yes, ions of the reactants, here, my dear students, silver nitrate have silver positive ion and nitrate negative ion. And sodium chloride consists of sodium positive ion and chlorine negative ion. When they react with each other, it is easily to exchange of ions Ag positive, yes, with Cl negative to give AgCl, while Na positive react with NaNO3 to give NaNO3, and this reaction take place faster. But in case of covalent compounds, usually react slowly. Why, my dear students? As we said, covalent compounds usually react slowly. Because what? Because the reaction happens between molecules which require breaking bonds at first between atoms of the molecules. Then the atoms combine to form new bonds. Here, my dear students, we need more energy to break down the bond between the molecules of compound. Now, my dear students, let's move to the second item that depends on the nature of the reactants. This item is the surface area of the reactants. I want you to listen carefully and try to think and observe. What happens, my dear students, if we take 1 gram of zinc as one piece and put it in a certain amount of hydrochloric acid? I want you to be concentrated. We have 1 gram of zinc as a piece, one piece, and put it in a certain amount of hydrochloric acid. In other hand, we have 1 gram of zinc powder, not one piece, and put it in the same amount of hydrochloric acid. Here we have two test tubes. One of them contain 1 gram of zinc as one piece in a certain amount of hydrochloric acid, and the other test tube contain 1 gram of zinc powder in the same amount of hydrochloric acid. I want you to observe the result in the two cases. Yes? Excellent, my dear students. The reaction in case of zinc powder, yes, occurs quickly. Why, my dear students? Yes, because the surface area of the reactant increase. This gives a chance to more react or react faster. So, if the surface area of the reactant increase, yes, excellent, the rate of reaction increase. Yes, my dear students, I want you to be concentrated and understand it for, yes, the two cases. If we notice the 1 gram as one piece and 1 gram as powder, we notice the reaction, yes, takes place faster in case of powder due to the increase of the surface area of the reactants that put in hydrochloric acid. وبكده أبنائي وبناتي نكون وصلنا لنهاية حلقتنا النهاردة اللي اتكلمنا فيها على الكيميكال اكوليبريم أو التوازن الكيميائي. والتوازن الكيميائي في بدايته احنا شرحنا مع بعض يعني ايه فيزيكال اكوليبريم أو توازن طبيعي، ونقدر نفهم الفرق ما بين التوازن الطبيعي اللي احنا بنلاحظه في بعض الدورات للعناصر زي ما قلنا، والتوازن الكيميائي اللي هو بيعتمد على التفاعل الكيميائي اللي احنا زي ما اتفقنا بيكون yes reversible chemical reaction. وبكده أبنائي وبناتي نصل إلى نهاية حلقتنا النهاردة. في انتظاركم إن شاء الله الحلقة الجاية. نتمنى لكم التوفيق والتركيز في المذاكرة والنجاح الباهر إن شاء الله. إلى أن ألقاكم، لكم تحياتي.